Hi guys, welcome to B Bytes Data Science course, lecture 9. So, in the last lecture also we discussed about what is EDA. Data has two types, right? We discussed about measures of variance, measures of dispersion, central tendency, mean, median, mode have been discussed thoroughly, right? We discussed about standard deviation and variance. But you should be aware that standard deviation and variance are both very different. We know that standard deviation is the root of variance. But do you know how these are related to the data spreadability, right? How data spreads, and then you can say that standard deviation is high and low, right? So today we are going to discuss that. And in the last lecture, in the end of the last lecture, I discussed about moment, right? So moment was discussed in the last lecture, but now we are going to discuss about the formula. What is the formula? How to calculate the moment, right? In the last lecture I told you that moment is calculated basically for four types, right? For four types of the values, right? So it has r in the subscript also. So r is the range from 1 to 4, right? R is having the value from 1 to 4, right? So basically there are three types of series that we discussed in the last lecture, right? So here the series was individual, discrete and continuous. So moment, that is mu r, is having different values for the individual and discrete and continuous series, right? In the last lecture we discussed that individual series we have only one value, means we calculate about only the one value, right? But in the discrete we find the cumulative frequency, right? What is cumulative frequency? We will be discussing in the numerical part also, right? You have studied earlier also how to calculate the cumulative frequency. It's very easy, right? For basically you have a table, in that table you have just some values, and you just keep on adding first two values, then the other and the other, then you just keep on writing the cumulative frequency in the next column, right? But when we move on to continuous series, now you know that continuous means that can be measured only, that cannot be counted. But discrete is finite, it cannot be counted but not measured. Discrete has some units, but continuous doesn't have any units, right? We discussed in the last lecture, right? So in the continuous series you must calculate the cumulative frequency along with the midpoint, right? Means when the data seems like this 16, you can say 16.5 to 20, right? And the another one, it can be 20.5 to 24. You can see that the data is neither individual nor discrete. Means in the individual we have single values like 16, 20, 24, 28, that is individual, right? And when the data will be like that 16 to 20, 20 to 24, 24 to 28, that will be discrete. But here you can say that it is neither discrete nor individual, it is the cumulative, it is the continuous series, right? It is a continuous series of data. So here you calculate the cumulative frequency. You will have to calculate the CF, that is cumulative frequency. Along with that you have to calculate the midpoint. Midpoint means you have to just add the lower and upper value and divide that by 2, right? That will be the midpoint. So in the continuous series you have to calculate the midpoint, right? And we will solve the numericals, and there will be calculating the midpoint in the continuous series, and cumulative frequency in the discrete series. And individual, that is simple, right? That is a simple numerical. But when we calculate the moment for individual, it is simple, that you just have to subtract. Means here you can say that capital X is the data point, right? Here the capital X is data point, X bar is the mean of all those data points, and capital N is the number of values. Now you have to remember that capital N is having different values for individual, discrete and continuous series. You can say in individual series, N means the number of observations, right? But when you talk about the discrete But when you talk about the discrete and continuous series, there n means the number of there n means the sum of observations. This is the point to remember. This is very important point, right? When you calculate the numericals related to the individual series where we have only a single value, on that, in that numerical we will be taking the capital N as the number of observations. But when you calculate in the discrete and continuous series, in discrete you have to calculate CF, and in the continuous you have to calculate midpoint and CF, right? So there N will be the sum of observations, right? And R, you already know that R is having the range from 1 to 4. If I say mu1, you will just simply put R equal to 1 in this formula. If I say mu2, you will put R equal to 2, and similarly with 3 and 4, right? So in individual, you just have to do nothing. You have to just subtract the mean with each of the data point, right? And then you have to calculate the sigma, means you have to add all them, and then you have to divide it by the number of observations. But before that, you have to keep in mind that what is the value of R. If R equal to 1, then it is simply like this. But if R equal to 2, you have to just do the square of all those value, and then you have to do the sigma of them, then you have to add them. So this is very important. And when you calculate the discrete and continuous series, you have to just multiply the whole formula by f by the frequency. Frequency means how many number of times the data points are repeated. This is very important. The numericals will be in the next video of this also, right? And when I say, so this was about the moment, right? How to calculate moment in individual, discrete and continuous series. In individual, just calculate by the help of this formula, but in discrete and continuous, there the concept comes of frequency, right? Frequency concept is in discrete and continuous series, but not in the individual. So this was how to calculate the moment in different series. But here you come that when I say the moment, the central moment, right? So that means the moment of mean. It will be coming in you can say many other concepts also. In the big concept, there the questions is asked that what do you mean by the central moment, right? Central moment is nothing but the moment of mean. By the moment of mean, that is calculated by the help of mean. Basically the meaning is this, right? Now come to the part of data science. In data science, till now we have studied that it helps to analyze and predicate the value, right? We just firstly analyze what is the data, and then we predict something as the output of that data, as the conclusion of the data, right? So this is basically the two parts of the data science. Now come to the standard deviation and variance, right? The most important parts in the you can say the measures of dispersion. So standard deviation, how it is different from the variance. We say that standard deviation is sigma and variance is sigma square. But what does that mean, right? How do they differ in the form of definition? How do you define standard deviation and variance? So basically, standard deviation, it indicates how spread out the values are. It indicates how spread out the values are, right? Means how spread out your data is. If I give you a number of values and you just say they are not close to the mean, they are spreading out widely, right? They have a wide range. That is the standard deviation. That is the high standard deviation, right? Standard deviation has two types, basically high and low. But when we talk about variance, it describes how spread out the values are. It gives a brief description of those values. And the standard deviation, it gives the indication of those values. But when I say that standard deviation is high, so it basically the values are highly spread out and have a wide range, right? The values are not close to the mean, they have a wide range, right? They are spread out widely. But when I say the standard deviation is low, then the values are close to the mean. They are not spread out widely, they are just close to the mean value, right? So this is all about the standard deviation and variance. So now we have to move to the another part, that is the mean, right? We discussed about median, discussed about mode, but what about the mean? So mean is nothing but the average value of a data set, right? Means if we have some values and you just calculate the average, you find the mean of that data. But mean is also in different types, and mean has three different types, that is arithmetic mean, harmonic mean and geometric mean, right? From the names you can understand arithmetic means only the simple mean that you calculate by the simple method, that some values are there and you find their sum and you divide it by the number of observations, the number of values, right? But what about the harmonic mean? Harmonic mean, you can say the question comes many times that which type of the mean gives the most accurate value, right? That is the harmonic mean. Harmonic mean helps to calculate the most accurate value. Means mean is the value, mean is the measure of central tendency that is used to find the most average, used to find the accurate value. But which type of mean helps to calculate the most average value, that is the most accurate value, that is the harmonic mean, right? So it calculates the most accurate value na. So we are going to discuss the steps how to calculate the harmonic mean, which helps us to calculate the accurate value. And geometric mean, it's basically based on the concept of GP, geometric progression, right? That will also be discussed in the further videos. But here the most important is harmonic mean. Simple mean you know how to calculate, right? But how to calculate harmonic mean? Basically harmonic mean is also very easy. There are some values given to you, right? You suppose these are xi means the data points, right? Xi means the data points. So these are the values, these are the xi data, right? You have to do nothing, you have to do reciprocal of all these values, that is 1 has a reciprocal 1 by 3, 1 by 5, 1 by 7, 1 by 9 and 1 by 11, right? So now you have to do the sum. These are the steps. The first step is done, do the reciprocal of all data points, then you have to find the sum of all these, sum of all the reciprocals, right? So that is the sum, right? And you have to divide the sum by the number of data points. So 1 3 5 7 9 11, it is 6, so you have to divide, and this is the harmonic mean. The answer will be right here, right? You will find the answer of the harmonic mean of this data, right? So harmonic mean, it is the type of mean that helps to calculate you the most average value. Means wherever you see that there is a big and large data set in the Excel and you have to calculate the most accurate value that is most suitable for your model to work upon, right? So in that case you have to use harmonic mean. You will neither use arithmetic and nor use the geometric, right? That will be arithmetic is very easy. It is used for smaller calculations, right, where you have low range of data set. But geometric mean, it helps in GP, means in geometric progression, that is complex. But the thing between these two is harmonic mean, right? It gives the most accurate value. So till now we have discussed about mean, right, median, mode, standard deviation and variance. In next video we will go further deep into the IQR and that part also. So thank you guys, have a nice day.